Lesson 48, radical equations. A few things to remember as we start this lesson. We're dealing with equations, of course, so we're going to be solving for a variable, solving for an unknown. Keep in mind when you're solving multiple step equations, what you do to one side, you must do to the other. What you do to one side, you must do to the other. Also, in these types of equations, we are going to check the answers to make sure that they are real solutions for the problem. Sometimes we'll get a number as an answer, and it won't be an actual solution, meaning it won't make the equation true. So in these types of equations, we need to check your answers. We're going to do this by substitution. All right, let's look at an example. The first example that we have is the square root of x minus 4 minus 2 equals 6. Keep in mind when you're solving equations, the main objective is to get that variable isolated. So we want that variable on one side of the equation by itself. Right here we have a variable that is within a root. So we can't do anything with the root yet. What we need to do first is go ahead and get rid of this 2. So in order to get rid of it, we're going to add it to the other side of the equation. And we're left with x minus 4, and the square root symbol equals 8. We learned a few lessons ago that in order to get rid of the square root symbol, we need to square. And that square will cancel out our square root. So we're going to square this side of the equation. And keep in mind, what you do to one side, you have to do to the other. So we're going to go ahead and square the 8 as well. When we square a square root, we simply get what is inside the root symbol. And then 8 squared is 64. Now we have a nice simple equation, x minus 4 equals 64. So to solve for x, we're going to add 4 to both sides. And we've got x is equal to 68. Now this is the answer for x, but we need to check the solution to make sure that it actually is a solution to the equation. Make sure that it will actually make the equation true. So what we're going to do is substitute 68 in for x. So we have the square root of 68 minus 4 minus 2, and it should equal 6. Well, 68 minus 4 is 64. The square root of 64 is 8. And 8 minus 2 is 6. So this solution checks. You must check every time you do one of these problems to see that the solution is true. I'm going to show you why in just a second. Let's look at another example. The next example, the square root of x plus 4 plus 2 equals negative 7. We're going to solve this one the same way. We want to isolate that variable. But first we need to subtract 2 from both sides. We're going to go ahead and subtract 2. And we're left with the square root of x plus 4 equals negative 9. Again, to get rid of that square root, we square both sides. And the square root of x plus 4 squared is x plus 4. Negative 9 squared is 81. And to solve for x, we're going to subtract 4 from both sides. And x is equal to 77. Okay, that's the answer. Now we need to check it to see if it's a solution. So we're going to substitute it back into the equation. We have the square root of 77 plus 4 plus 2. We're going to see if it equals negative 7. Well, 77 plus 4 is 81. The square root of 81 is 9. 9 plus 2 is 11, and 11 does not equal negative 7. So what we would do at this point is either do an empty set, which is a circle with a line through it, or write no solution. Let's try one that looks a little longer, a little harder. We have the square root of x squared plus 2x plus 13 minus 3 equals x. All right, what we want to do first, since we can't do anything with this square root symbol until we move this negative 3 over, we want to go ahead and add this 3 to both sides. So now we have x squared plus 2x plus 13 equals x plus 3. To get rid of that square root symbol, we're going to square both sides. And keep in mind, when we square x plus 3, we're really doing x plus 3 times x plus 3. Okay, over here, the square root and the square cancel out, so we have x squared plus 2x plus 13. And then we need to distribute x plus 3 times x plus 3. We distribute, we will get x squared plus 6x plus 9. Now we can solve for x. Now we have an x squared on one side, and we have an x squared on the other side. We can go ahead and cancel those out, because if we subtract one from the other, we'll end up getting rid of them anyway. Then we want to get that x on one side. I'm going to subtract 2x from both sides. And at the same time, I'm going to subtract 9 from both sides. That way I have all of the constants on one side and all of the variables on the other. 13 minus 9 is 4. And 6x minus 2x is 4x. If we divide, we get x is equal to 1. All we need to do is substitute then that back into the equation to see if 1 is actually a real solution. So, let's shrink this. We have some room to work. All right, if I substitute, I have 1 squared plus 2 times 1 plus 13 minus 3, and it should equal 1. Well, 1 squared is 1. 2 times 1 is 2. 1 plus 2 is 3. 3 plus 13 is 16. So I've got the square root of 16 minus 3. The square root of 16 is 4. 4 minus 3 is 1. 1 is equal to 1, so it checks. 1 is a real solution to the equation. All right, I'm going to write 2 examples up on the board. I want you to go ahead and solve these 2 examples, and we will go over them in class. The first one is the square root of x minus 3 equals 5. The next one is the square root of x squared plus 3x minus 10 plus 2 equals x. Keep in mind as you're doing these that you need to check to make sure that the solution is a real solution.